Okay, I wanted to solve this problem from the logarithmic chapter, our final chapter of this semester. This is actually from section 9.3, which deals with exponential and logarithmic functions because essentially uh, they are the same thing. In other words, that what we can do is we can rewrite this as a exponential equation. And that's what I want to do. That's usually the more familiar for me notation. And I have a trick, an algorithm that puts this move on autopilot for me. Essentially, let's read this here. This says the log to the base x of 9 is equal to 1/2. That's how you would read that out loud from your textbook. Log to the base x. Now, the algorithm and my way of autopiloting that is just to realize that the base of the logarithmic equation becomes the base of the exponential equation. So I'm going to have a base of x, and the question is what power here? And so again, my algorithm is pretty simple. It says what we do is we take these two other numbers and they change sides. So that's just a recipe, an algorithm for handling this translation to an exponential equation. The 1/2 is going to come to the other side as the exponent, and the 9 is going to go to the other side like so. So there's a successful translation from logarithmic equation to exponential equation. And at this point in time, I could see two different paths to solving this. One path is to write this in terms of radicals. This is x to the 1/2 power, which I'm sure you remember is the same as the square root of x. And the right side is 9. Now I think in this form, it's even more transparent in this form as to what x must be. Why, the square root of 81 is equal to 9. And so, there's the answer. Well, like I said, there's at least two paths to solution once you get to this point. And the other path is to raise both sides to the second power. Essentially, when you have powers to powers, you multiply. So you're going to have 2 to the 2 over 2, or simply x to the first, or simply x. And on the right side, you're going to have 9 squared, or 81. So either path gets you home. And I think the main idea here was this translation from logarithmic to exponential equation. That's fundamental. And my autopilot technique of keeping the base the same and switching these numbers to the opposite sides of the equal sign. Now, one final note here. One of the things I tried to tell you in my notes is that when you see something like this, this is an exponent. I know it doesn't look like an exponent, but it is an exponent. And since this is an exponent, that means this has got to be an exponent because they're equal. And as you can see, indeed, the right side does end up as the exponent. So I want you to pay attention to that sort of thinking too, that this is an exponent. Whenever you see logs, they are defining an actual exponent, in this case 1/2. Okay, I hope that helps. I'm going to work some other problems in a forthcoming section, so I'm not quite done talking to you this semester. See you in a bit.